Hello, everyone. Welcome to the first Logic Apps Live of 2024. And as you can see, we have like a big team today. So for everyone that is joining us, Happy New Year. And if anyone from the team wants to say hi, feel free to open your camera and your microphone to talk.
Hello, hello.
Hi, everyone.
Come on,
Thanks
don't
for
be shy,
joining
people.
us. Thanks for joining us. Exciting year ahead of us. So buckle up.
Hello from Toronto.
Let's move on to our content. And there we go. Actually, that should be better. Okay, so we have a full agenda today, right? As now is becoming tradition, Alex is going to talk a little bit about our Ace Aviator of the month. Every month, we're trying to highlight people in the community that is joining, helping us to drive Logic Apps and add content, discuss new things. So Alex is going to be highlighting who was the Ace Aviation for Aviator for January. Then Kent is going to be talking about the business process tracking with a new functionality that is in preview right now. Harold is going to be talking about the new connectors for IBM I environments. Divya and Aprana that just joined us is on the backstage. Just let me bring Aprana here. There she is. So they're going to be talking about the service bus sessions and concurrency. So we have new updates on that. And I know that people is going to be quite excited about that. Beza is going to be talking about target-based scaling. There is a new offering that we added to improve performance on scaling in and out for Logic Apps Standard. And Path that is driving home to join us. So this will be probably the coming really soon, is going to be talking about some OpenAI connectors. As usual, like share your comments, share the things that you enjoy or not on the session. And if you have time, we're going to be through a Q&A at the end. With that, I'll pass it on to Alex and the Logic App Aviator of the month.
Thanks, Wagner. All right, guys. So for this month, our very first 2024 Ace Aviator is Mark Brimble. So Mark Brimble has definitely been involved with Microsoft for a little bit. So in case you don't know who Mark is, just a little bit about him. He's an integration architect at Bid1. And then two little fun facts that we've got for you from his interview is one of the tips he mentioned is practice presenting. When we asked Mark kind of, what would help you grow professionally, he said presenting, because you truly won't understand anything unless you're able to teach it and talk about it. And then one of the quotes we pulled from his little interview was, take some risks because you will learn from any failures. So definitely go check out our new 2024 January newsletter. And it features Mark, and take a little more read and learn from him. And also read up and catch up on all of our new updates from the beginning of the year. And congrats to Mark, of course.
Thanks, Alex, and thanks, Mark, for being part of our community. So first up, let's talk about business process tracking and parallelism and conditions. So this was some feedback or questions that have come up quite frequently, especially when we had launched this in November around the Ignite timeframe. And there was a question about, in the examples, we see a lot of like sequential processing, and can business process tracking be used where you've got some more optionality, some more complex scenarios. And so this is an example that we've borrowed from the fundamentals of BPM. There's a link there. And this is a BPMN diagram that talks about an order to cache scenario. And as part of this, you can see that we're going to go ahead and check for some stock availability. Depending upon the availability, we're going to go one of two directions, and hence the term XOR split, right? We can either go ahead and reject the order, or we can go ahead and confirm the order and subsequently move to the next step of the business process. Now, in this case, we're going to now introduce some concurrency or some parallelism, where we're going to go ahead and ship the goods and send the invoice at the same time. And essentially what we're doing here is fanning out. And then what we're going to be able to do is to fan in, and then go ahead and complete the order by archiving it once we've gone ahead and completed those specific actions. So to help illustrate this, I'm using one of Microsoft's fictional companies called Fourth Coffee, which is appropriately named in my case. And this is just a shout out. This is the Microsoft Designer. So this is a logo that was generated through the power of AI. So if you haven't checked out the Microsoft Designer, go check that out. It's a pretty cool tool. So Fourth Coffee sells coffee to other coffee shops and also direct to consumer. They've got an online ordering process. And from a business perspective, we'd like to be able to track these orders. And we'd also like to be able to track orders where inventory cannot be fulfilled. That provides us with some analytics. Maybe it means we need to ramp up on production for specific goods that are frequently out of stock. So let's go ahead and let's jump into a demo, and I'll show you this, or I guess live in action. So maybe before I do that, this is just sort of the outcome that you're going to expect to see as part of the demos. And you can see here that I've modeled the business process very much like that diagram. So in this case, the left image represents the happy path where we do have stock availability. You can see that we do go ahead and evaluate some condition here, and then we go ahead and process the order. On the flip side, this is a situation where it represents us not having the actual stock. So one important distinction here when we think about business process, the business process tracking and the designer. The designer doesn't enforce the implementation. The designer reflects what the implementation is. So when we think about these conditions and when we think about concurrency, your workflow implementation under the hood needs to actually implement those patterns. When you do so, what you can do is layer this on top and it's going to accurately reflect it. So let's head over to the Azure portal. And let's just head into I'm in an environment, and then I'm in a specific business process. Let's just jump through that. My breadcrumbs got removed. So here's the Fourth Coffee e-commerce dev environment. I've got one application in place. It's called Order to Cash. If we go ahead and explore this application, what we're going to see is a service bus namespace, which has 4 queues. We're also going to go ahead and see a series of workflows that actually support the processing of our coffee orders. So here we've got our business process. Now I've already gone ahead and designed it. If this is the first time that you've seen the business process designer, it's a very sort of familiar experience. It's something where you can easily go ahead and add a stage. You add a stage, you provide some additional details. You talk about the data properties that you'd like to collect at that particular stage. And then you can also go ahead and introduce a parallel stage. So I can go ahead and click above the stage that I want to add some parallelism to, and then go ahead and build it out. And from that perspective, I can further add to those stages as I see fit. When it comes time to converging or fanning back in, I can go ahead and drag from the node, the stage back into like a subsequent stage. And when I do that, it's going to go ahead and unify these connections. Otherwise, it would be continue to be built out below the node above it. So that's how you go ahead and you construct these particular business processes. And once you've done that and you've constructed the logical business process, this is where you can go ahead and perform some mapping. So for a particular stage, I'm going to select a specific workflow. And in this case, I'm going to grab data from my trigger. I can use my dynamic content and my expressions as a way to go ahead and capture the specific details that I'm interested in. After I've gone ahead and done that, I can go ahead and deploy it. And I will now have a business process that's ready to go ahead and capture these transactions. I can view transactions by clicking on that particular icon. And now I can go ahead and submit some messages to my workflows. So this is essentially my on-ramp. This is my receive order workflow. I can go ahead and pass in a payload. We're going to go happy path here. So I've got a payload. I'm going to check for a couple different products. And I know that if I'm looking for 10, that those will be in stock. Let's just make sure I've got a unique order ID here. And I'll go ahead and click the run button that's now been submitted. If I head over to my transactions, you can see that that's pretty snappy. That happened in very much near real time. And we can go ahead and see the execution of that particular business process. For each of these stages, I can go ahead and check out the values that were captured as part of that execution. So let's now just go and do the inverse of that. Let's go ahead and submit a message where we don't have enough inventory. So if we go ahead and, say we want to order 100,000 of product 001, once again, let's make sure we've got a unique order ID here. Let's go ahead and run that. If we head back over to our business process transactions view, we can see that that's also processed here as well. And in this case, we can see that our product is not in stock, and we could subsequently, get additional details as we see fit as well. So we got lots on the docket today, so I'll leave it there, but feel free to ask any questions in chat, and there's some other videos on this topic as well. All right, so over to you, Harold.
Thank you, Ken. Okay, so let's get started then. First of all, imagine all of the capabilities that you just saw now extending to this legacy world of IBM I environments. IBM I environments are they used to be called AS400 in the past, and they are also known as mid-ranges today. Do you mind going to the next one, please, Ken? Thank you. And what we have recently introduced is just one connector that allows you to call IBM I programs that are coded in RPG or in COBOL. So these RPG programs or COBOL programs running on IBM I environments, they can run on premises in an IBM I system, in a power system, or they can run in the cloud with a SkyTab, for instance. What we are going to see soon is, do you mind going to the next one, please, Ken? Is basically a demonstration of how is it that you can use logic apps to interact with these smaller mainframes, let's call them, right, mid-range system. A few things to say before getting into the demo is the first one is that our IBM I integration technologies, they use TCP/IP, and they use a server inside the IBM I system that is called DPC, or distribute program call, that allows you to do invocation of programs remotely. Right, so if you do need SNA over IP connectivity, so then you will need to install host integration server. But if you don't need SNA, so then you can just use the connector, and then you can interact easily from a workflow. For that, you will have to follow a few steps. Like, for instance, you will have to create an object, an artifact that maps the data, the program that you have in the mid-range, in the IBM I system, with something that can be read by the workflow. But let's see how that happens. Do you mind going to the next one, please, Kent? Thank you. So let's now switch to the environment. So right now I'm showing an SkyTab environment that has IBM I system. So what I'm going to do is I'm going to show you the program that I'm going to be interacting with against. So this is the IBM I environment. What I'm going to do is I'm going to show you I'm going to see members here. I have the file library name type. Hit enter. Then my program is called Cedar Bank. I'm going to go. I'm going to see the program description. This is a program that we use for sample, for demo purposes. So it's a fairly simple get balance program, and what it does is just returns a very simple balance in this case, right? It's pretty self-descriptive, right? So then now, so if this is your program in your environment, what you will be needing is to create. To mirror this program in what we call a host integration definition XML file, or HIDX file, that basically will represent this program that is running in the IBM I system, and that will allow you to do a manipulation of parameters, and you will have more freedom to do anything with this, because remember that we're talking about different environments, right? So it's fairly it's fairly easier to just work with these HIDX files that allow you to do operation on nested fields and nested application, nested fields or data types. So you really don't want to operate in RPG, believe me. What you want to do is you want to operate with something that is as easy as using an HIDX file that is part of is the outcome of the host integration server designer for logic apps, which is a tool that you can download to create these definitions that will mirror your programs in the host environments. Now, if I go to the workflow that I just created, what I do is I just receive a simple request, and then I add the connector. To add a connector, I just add an action, and then I add here IBMI. I will add a call an IBM program action, and I should what I should do is I should upload the HIDX file that I just created, and also enter the parameters that are needed to call this object, right? So in the particular case of this program, what I'm going to do is, well, I'm going to show you how easy to create a new connection, because you will be needing the connection information to get to this environment. And this is the beauty of it, right? So you don't need to go to anywhere else or to pay a token or to get a license or anything like that to go into the IBMI environment. This is a built-in connector, so it's part of the compute of your Logic Apps standard. So that means that this is pretty much included because as a built-in connector, you are already in the standard tier. So then what I'm going to do is I'm going to discard these changes that I made, and I'm going to run it now. So I'll go overview, run, and then that's it, right? So I'll go to the details of the execution, and you'll see that this is an IBMI program call. We just call this program call Cedar Bank, right? We send these parameters, and then we got the response that we just saw in the mid-range program. So I invite you to look into the HIS Designer for Logic Apps, which is the tool that we have available for creating this mapping, because the pattern that we follow for all the mainframe and mid-ranges connectors is fairly similar. You have to have access to the program via TCP/IP, to the environment and program via TCP/IP, and then you should also create a definition of this program so the workflow can understand it, and then you can use it and then do any operation if you would in the mainframe or mid-range environment. And that was it. Thank you.
All right.
So adding Divya now, because you're going to be talking about something that a lot of people is going to be interested. So we're going to be talking about service bus, sessions, and concurrency. And with us, we have Divya and Aprana. All yours.
Yeah. Thank you, Wagner. So I really look forward to give an intro on some of the recent enhancements we've done with Service Bus built-in connector. And I think more than that, I look forward to have a conversation with Aparna, who is like our resident expert on these things. So I look forward to that chat as well. So first of all, just to give you an update on what features we have recently released. Again, like these have been asked by customers, and we know that these are being used by customers for many scenarios. So hopefully, like we look forward to your feedback and excited to share this with you. So the first one is around the support for sessions, where sessions provides a way for you to group related messages together and to process them in an in-order way. And the way you establish correlation between the messages is using a session ID. So for those who have already used Service Bus, you know that this can be used to build common patterns like sequential convoy. And that's what we are showing on the right hand side, where you can, using a sender, create a group of messages that are correlated using a session ID and write them to a common Service Bus queue. And then the trigger, which is session aware, is able to read those messages by session IDs, which you can configure using the new capabilities that we have released. So as you can see in the screenshots there, we do have a couple of triggers that can now take in your session ID and some other parameters such as the batch size of the trigger should read, along with some other configurations that we'll go into more details later, which can then enable you to process these messages in an in-order way and correlated via the session ID. We have published a blog post on this, so feel free to take a look at the blog post and reach out to us if you have any questions afterwards. Can we move on to the next one? Concurrency control is another feature that we have released for Service Bus Trigger. So by default, Logic Apps will try to process messages to full capacity. But in some cases, customers want to avoid performance bottlenecks because your applications or systems upstream or downstream may not be able to process with the same throughput, or you want to control burst traffic and have better optimized throughput overall end to end. So in those cases, you can use concurrency control feature where using certain configuration that will again talk more, you can control basically the number of concurrent runs that are instantiated for a workflow, as well as the batch size of the messages that are read by the trigger and the number of waiting runs. So by using a combination of these configurations, you have control over the processing of these messages, and thereby you can have a pattern where you can control, where you can prevent your backend applications by not overwhelming them through with messages that they can't handle. So again, we'll talk more into these features, but we have already released these capabilities, and there is a blog post that talks more about it, on how you can use this and how you can enable these while you're using these features. So with that, I want to move on to the next section of today, where I want to have a chat with Aparna, who's actually the expert in our team on messaging and everything messaging related scenarios. So I think let's start with a quick introduction from Aparna.
Hey everyone. Uh, hey everyone. This is Aparna. I'm an engineer on the Logic Apps team. I have been working on the managed connectors. Initially, I started with that, like service, all the messaging connectors, Service Bus, Event Hub, SFTP, and then moved them into the Logic Apps standard. And currently, I'm working on providing other features in the Logic Apps backend.
Yeah, thank you. So Aparna is our messaging champion here. So with that, Aparna, let's get into the questions. So I think let's start with a high level one first, where if you can elaborate onto what are some of the differences between the service provider based or like the built-in service provider connector versus managed connector, which people are more familiar with coming in from consumption and ICE.
So obviously, the service provider connector, it provides you all the goodness of the service providers, like they are pretty fast, and you don't have any connection limits as we have on the managed connectors. Along with that, the connector in the built-in connector that is using AMQP protocol, which is the standard for the messaging, and there you can use the large messages as well, which is provided by Service Bus. And by nature, it internally uses the functions trigger, and the functions trigger by nature is very fast. It goes and continuously it looks up more messages in the queues, and it can get messages up to 1000 per node. So let's say if you have 10 machines which are going against reading a particular queue within your Logic app, in that case, we in parallel, those 10 machines will be getting up to 1000 messages in every go. And with the stateful workflow, you can really go pretty fast and then process all those messages really quickly.
All right, so I think that's a good segue into the features that we have released, and because it's built on functions and it's so fast, concurrency control even becomes more important, right? So Can you explain like how concurrency control actually works with service provider?
So, like I said, the functions triggers are pretty fast. So they will continue to read, fetch more messages. So we came up with a design wherein there is some sort of communication between logic apps engine and the functions trigger, wherein we kind of give a loop back control and say continuously provide a feedback to the functions trigger and ask it to stop for some time, so that the current based upon whatever concurrency you have set on the trigger definition, based upon that we can slow down the trigger and then pull more only if the current concurrent runs which are running are completed, and then get more data, so that provides more control on things.
Okay, so with that, I think Aparna, let's jump into some of the configuration that customers can use to control this behavior. And before we start on that, Wagner, can you please share the screen so that we can have a reference on the screen on what we are discussing?
Yeah, I'll just do that now and share the screen. There we go.
All right. So, Aparna, like, can you talk about like what kind of configurations play a role in the in controlling the concurrency?
Yeah, so one of the important thing is that how much trigger is pulling already, which is the functions trigger behind the scenes we are using, right? So that is the configuration which gets defined in the host or JSON, and you specify what is the maximum message count, which is kind of equivalent to what we used to have maximum message count as an entry on our as a property in the trigger definition in managed world. So that kind of defines how many messages the trigger is pulling in at a time. And then there are certain configurations which you have to do at the logic apps workflow definition itself, in the trigger runtime configuration, wherein you say what are the concurrent number of runs you want to have and what are the waiting runs. So concurrent runs is basically that decides how many parallel runs you can have at a time. And then there is another configuration related to the maximum waiting runs. So waiting runs is something which defines like how much how much backlog logic app is keeping. Essentially what happens is that functions trigger has got something. So it's not just specific to the service bus. In general, how concurrency works is some trigger has picked up a batch, logic apps maintains a dispatching queue for it, and then we push things to the queue. And based upon these concurrency settings, what you have in the workflow definition, we will go and fetch more messages from the queue, process them. Once they are done, then we will go and get more. So be very cautious when you are setting all these settings. The key thing here is when you set the concurrent number of runs, ensure that it is lower than whatever value you have for the maximum batch size, which is defined on the trigger configuration, which goes in host or JSON.
All right. In terms of the batch size, anything else that is important? Can customers like see batch size different than what they have configured?
Yeah, so one thing is that whenever we say batch size, that is like it is up to service bus how many messages it can give us, but that is a higher cap, so you can get up to those many messages. Like if let's say you have 100, you can get 200 messages, but that's all on the discretion of how service bus SDK is able to internally, the client and server are interacting with one another and how they are able to pull more messages.
Okay, and you also talked about concurrent runs and waiting runs. How does this work hand in hand?
So, like I said, we maintain a queue in the Logic Apps engine, right? So that what is the queue depth, how much we are going to put in the queue is all dependent upon the maximum waiting runs, how many you have defined. And the default value for that is like 10 plus whatever concurrent runs you have defined. But it can go beyond that also, depending upon how much trigger has got. The thing is that once the trigger has received, let's say 100 messages, but you are saying only you have 10 you can have 10 waiting runs, but Logic Apps engine doesn't know what to do with other 90 messages, but we will put all those whatever is left over in the waiting runs. So be very cautious when you set these values, because once the message is read from service bus, the clock is ticking on the lock duration. So if we are not able to complete the messages in appropriate time, then we will lose the lock and the messages will reappear on the queue. So adjust these settings in such a way that it handles the appropriate scenario which you are looking for, and ensure from our side the recommendation is that you should ensure that the concurrent runs are always lesser than equivalent to the batch size.
All right. Yeah. Thank you. I think this will be very helpful for folks who are trying to use concurrency and playing with these settings for their scenarios. So yeah, thank you, Parna, and feel free to reach out to us if you have more questions specific to your scenario. So with that, I want to context switch into the another capability where we were talking about sessions, right? So as you had as we had shown, Aparna, like we have actually introduced new triggers to support sessions. So can you just speak to that? Like, why did we bring this capability via new triggers?
So it's by nature from functions trigger works in a bit different way when it comes to sessions, other than like what we have exposed things in managed world, wherein you can fetch parallel sessions at a time and then you are able to process those sessions. But how functions trigger work is that it gets a particular session, it continues to read more messages on that session. Once it is done with that session, then only it goes to the next session. We wanted to have that feature of multiple sessions at a time. That was primary reason, and other things were like of course coming up from service bus itself, that whichever receiver received the messages should be the one receiving other messages on that particular session. And we had to have control of that receiver appropriately, so we are able to close the messages, close the session appropriately, renew the session, and perform all the other actions like we have in the sequential convoy. To be able to support that scenario, it was better for us to have our own trigger, which gives us more flexibility around all those things.
Okay, so I think as you were explaining before, right? Like service providers bring this value in terms of like performance and flexibility. Customers have a lot more control. From the point of sessions, also, like, do customers get the benefit of more control and flexibility here?
Yeah, I would say that, because in managed connector, if you know exactly, we have several layers which are maintaining things. Like connector itself is a service, is a different service, is an app service, and then we have other layers like API management. So their customers have seen in the past like no session is available to complete the message, or this kind of problems wherein this can happen for several reasons. Like we did a deployment on the connector, or API deployment is going on, or some other infrastructure upgrades are going on. In those cases you can get those kind of problems. But here in standard, by nature itself, standard gives you all the control of deployments and other things which you can control on the app. With that, it makes things easier, and you might not see those kind of problems per se, which are happening from our shared environment. So of course the multi-tenant versus single tenant comes into picture here.
Yeah. And by design, because customers own the compute, they have control over configuration, they have control over when they update, when they patch these things. So it's not in their hands. Yeah, I think that's great. So I think I want to jump into one of the common questions we get on peak lock triggers, where customers today are required to use the fixed number of nodes or VMs. Any update on that? Is that still a constraint?
Yeah, so we have uplifted the constraint for some time. It's not like forever things will be available, but we have, for example, when you scale in that case, like machine is going down, we are keeping the machine up for 5 minutes. That is the thing which we are treating from our side. So it will be available for 5 minutes for you to be able to finish up the work on that machine. But beyond that, if you are trying to change some configurations at your end, or which has caused a restart, or you're deploying new workflows, any change on the file system, there will be restarts. Those are the things which are not controlled. But something, if scale in is the problem wherein you might see those kind of problems and you're not able to complete the messages, we are giving a leeway wherein the machine will be up for another 5 minutes for completion of the work which it started.
Yeah, and the reason we need those nodes is because we need to complete the session, the message that we get.
Yes.
And therefore we are giving this 5-minute time window where we have this extra buffer to complete.
Yeah, I think it's a good point you brought up. The reason we had to do that was because this is coming from, again, back to AMQP, not even service bus. AMQP implementation is in such a way that the channel which has read the message should be the one completing the message or performing any action on the message. So for us to do that, it happens through service bus receivers, which we get from the SDK. It is required the receiver on whichever node has picked up the message should be the one completing the message. So if that node is going down, we are keeping that alive for like 5 minutes so that you can finish up your work.
Okay, that's great to hear. And then I think one other question that we get is that we have this requirement that customers need to connect their app to VNet to use peak lock based and session based triggers. So for those who are doing development in VS Code locally, is that still a requirement for them, and how do they get around it?
So there is a workaround for that. Like there are 2 settings which you can set. We can share that later. Probably I don't think we documented that. So essentially what happens is when you enable the VNet, you get a particular port and you get a particular website ID. You just set those environment variables in your local settings JSON, and then you should be able to use that in your local environment without any issues.
All right. So I think this was great information. Hopefully, like customers can greatly benefit from it. And of course, like we have our blogs and we are always available to answer the questions. So to close our discussions, given you have worked on these complex features, anything you want to share in terms of like any challenges or tricky
I would say
situations?
concurrency was an interesting design. Like I said, functions trigger by nature is very fast. So bringing it down to the speed of the concurrent runs and all, that involved quite a lot of changes at several teams, a lot of discussions around the teams and getting things done, and managing their deployment cycles and everything so that everything lands in place. And before deployment of logic apps, workflow extension. So yeah, that was all challenging experience. And yeah, when Microsoft, we were able to put it together with all the teams.
Yeah, it's a great example of cross-team collaboration from design to testing to release. Yeah. So yeah, thank you so much, Aparna. This was great, and passing on to Wagner.
One quick thing that Harold asked us to share here from backstage is most of the things that Aparna discussed for concurrency is also supported, and actually the whole way that the thing works also applies to MQ, because MQ uses a similar approach, right?
No, I would like to add there. I think MQ should have been concurrency should be enabled there for forever, like because that follows a different model. It is a polling trigger, and the ones which we expose right now are the function-based triggers like service bus, event hub, key vault, and all those things which are powered by the functions triggers. Not key vault, I take back, blob actually. But MQ should have those already.
Yeah, and that's why I should be bringing him to the stage, because he was saying, actually, mate, I was talking about the VNet settings.
Yeah,
So,
exactly. No, exactly. I was referring to the VNet settings and the affinity requirement, right? So for us, so in the IBM MQ connector, we have something similar. We don't call it peak lock. We call it browse lock, and we also require the affinity implementation, right? Which is what Aparna mentioned as well. I just wanted to call that out. Okay.
Yeah. It should. Yeah, VNet is applicable to MQ as well, but the other part, concurrency, is different. That should have already been working in MQ.
We have that already with
Yeah. So the one which we introduce now is for function-based triggers, and that is currently available only for service bus. We are still working on other built-in connectors to ensure everything works fine. We have the basic infrastructure ready, but not validations and testing done for all those connectors.
That's great. Thank you.
and I think a good challenge for us on the PM team is having a quick blog post about the VNet settings by next week.
Yeah.
Cool. Thank you so much, Aparna and Div and Harold, for joining with on that one. Let me bring Beza to the stage, and then we can continue the discussion now on the target-based scaling.
Hey everyone, I'm Beyza. I'm a software engineer at Azure App Services, and today I'll be talking about the event-driven target-based scaling for Logic App Standard. And this work was completed in collaboration with Rohita Hevavasam and Nikhil Sira from the Logic Apps runtime team. So start off, I would like to briefly explain the current scaling logic and what we were looking to improve. So currently, the Logic App Standard uses incremental scaling, which basically adds or removes a maximum of one worker at new each instance rate. And then this scaling decision is taken at runtime. And this is based on primarily the job queue latency metric. So this logic comes with certain drawbacks. First of all, this incremental approach of one at a time is usually too slow, especially for our customers who need to handle high load batch workloads, and they want to drain those jobs that are sitting in the queue as soon as possible. And also incremental scaling tries to ensure that we don't overscale and waste capacity through slowly increasing the number of instances. But this actually comes as a frustration for scenarios where we need to handle high load batch workloads. And it also turns out that it does little to nothing for preventing overscaling, because even the apps that scale slowly can easily overscale. And then secondly, the queue latency isn't really a sufficient metric because it's not a legitimate signal for scaling in. And therefore, it makes it easy for the apps to be left as an overscale state. And it also complicates the instance allocation when the messages in the queues are retired and no longer need to be processed. So although the job queue latency metric can be helpful to decide on how much we can scale out, it doesn't really provide a good signal for scaling in, because if we have a queue latency of 0, it could either be, oh, we're perfectly good right now, we just have to keep the number of instances that we have, or, oh, we have too many instances and we don't really get the benefit of those extra instances and we're just billing the customers unnecessarily. Therefore, the queue latency gets a bit complicated, and then it could also result in our customers incurring more costs for the resources that are not really needed. And then also, we have to take historical samples of the job queue latency metric to be able to make decisions. However, this is not very helpful because the sampling and taking it, it will take a minute or two to make the first scaling decision. Therefore, it also requires a persistent storage for the metrics to be saved in, and this is also going to be an extra cost for us. Therefore, we decided to go with a new approach of target-based scaling, which basically calculates a specific number of worker instances to allocate for the workflow app at a given time, and this is based on the events that needs to be processed. And this logic is also, as you can see on your screen, is basically the job queue length divided by the target executions per instance. And then we multiply it with this target scaling factor that we have introduced. And this is a decimal value between 0.05 to 1. And this is added to ensure that our customers can control the degree of the scaling intensity. So the job queue length and the target scaling factor are, I assume, pretty much clear, but then we have this target executions per instance that is sitting at the denominator. And this is basically the maximum number of jobs a compute instance is expected to process at any given time. And for this value, we have two different approaches where the users can configure to calculate it. And it is dynamic or static concurrency at heart. So for static concurrency, this value is a fixed number that is set at configuration. You can do it through your host.json app configuration. And then our customers with the static concurrency setting enabled has complete control over the concurrency setting for the target-based scaling. For dynamic concurrency, the value is determined by the Logic App Engine during runtime by the backend, and then it adjusts the number of dispatcher worker instances based on workflow's nature and its current job processing status, with keeping in mind metrics such as the CPU utilization and so on and so forth. So we have some limitations from the scale controller and data role side within app services. Therefore, the scaling is still limited to 4 instances at a time. So we have that throttling in action. And also the maximum number of instances is still honored, that is set in the app setting configuration. And it's also important to note that the users who are using multiple storage accounts will be able to use a target-based scaling as well. We will just take a sum of all the queues across their job queues as the job queue length metric. And the target-based scaling will be enabled by default for Logic App Standard starting from late January to mid-February. And it's very easy to disable this as well. If you want to use incremental based scaling, you can just adjust your app setting, and then the instructions for that will be available at the link that we provided in the slides. And we look forward to your feedback, and we're very excited to roll out this feature.
Thanks, Beza. So a couple of questions on that one, although some of the questions that I had, I think you already answer. I think the first one that would be just reiterating, what is the biggest benefits that you see for customers with the target-based scaling?
Yes, the biggest benefit that we see are with customers who have scenarios where they get high batch workflows, and then they want to drain out the messages, the jobs in the queue as soon as possible. And the benefit that the target-based scaling provides is that because we can calculate the number of instances required at that time to be able to drain out the jobs in the queue, it's very faster for the application to ramp up its number of instances. Therefore, we reach to that target instance number almost half the time it takes compared to incremental scaling. And then the execution is much faster. And then once everything is completed, it's going to be faster for the application to go back to an idle state where the number of instances are low.
Mm-hmm. I remember yesterday you were discussing on the chat like one case where customers was scaling up to 100 instances, and you found exactly that, is that the time it took to get to those 100 instances was like almost half time of what had happened, which means that it probably was able to execute their workloads faster. So the overall performance of the Logic apps have the perception that it's faster, right? And also probably bring it back down to the idle state faster than it would be with the current scaling. And as you said, there is anything that customers would need to do for that to take advantage of this?
I believe that the target-based scaling is a very highly configurable feature that we have. And it's also important to note that the scenarios where our customers are not getting high batch workloads, instead they're getting sustained low workloads, may prefer to use incremental scaling because they're not going to see as much advantage as the ones who are getting many jobs instantly. And there are also 3 different settings that we have outlined in our blog post for announcements that are related to configuring the intensity of scaling out and scaling in for the Logic App Standard. And we would like them to check that blog post out first before applying the settings. And also it's important to note that if they would like to have more control over their target-based scaling logic, they can opt in to use static concurrency, where they define the target executions per instance value. However, this comes with some caveats as well. Although they will have more control over it, it also means that they will have to do a lot of trial and error testing out if it works or not to be able to ensure that they have the optimal value for the concurrency.
As the other settings in Logic apps is we're trying to get close to the 80% of the cases, we try to optimize for that. But if you have scenarios that are quite different from that, either too high throughput or like a sustained load, as you said, is always worth to do some performance testing, adjusting some of those concurrencies, right? and all the information that they need is on the blog post that we put it on the chat for them. The last question that I would have for you, that is more like a personal question. I think that's one of your first projects with the Logic Apps team, right? So like how it was working with something that is like that with the team. What is the experience that you have on that?
Thank you, Harold, for asking this. I was actually very happy to be able to join the runtime team for this project. I'm originally working as a data engineer at the analytics and growth hacking team, so it was a very new experience for me. And I was very much appreciative of my team's support throughout this process, and also the Logic Apps team as well. They always were helping out whenever I had questions, and I was able to learn a lot through this process. And it was also interesting to have cross-team collaborations, especially with the Azure Function Scale Controller team, because we work in conjunction with them for scaling our Logic Apps. And I also appreciate the support that they have provided throughout this project.
Awesome. This is really good that we see, like in two discussions that we have, two instances of one Microsoft working together, like across teams collaborating and helping out. And people seems to be really liking this too. I just got in this from Michael Stephenson. There's a cool overview of the feature and great work. So seems like people is quite interested on that one.
We're happy to hear that.
Good. Thank you so much for joining us today, and feel free to join us later if you wanted to have more information on that or any of the other projects that we're working on.
Thank you.
With that, let's bring our last participant today, but not least important, Mr. Parth.
Hey.
And it didn't go yet. There we go. Oh, yours, mate.
I'm just going to try and share my screen really quick. Just give me 1 second. It's giving me
No worries.
a little bit of a problem here. Let me do that in a second. Why don't I just go over the slides first? So, hey, everyone. I have about 4 minutes, so I'll try my best to, convey the news and seek your feedback, obviously. So, first things first, we are releasing the new connectors for public preview for OpenAI. These will really help you build like intelligent applications and leverage like OpenAI services alongside Logic Apps. I see the benefit here, not just with the connectors, but the overall ecosystem that Logic Apps has, and just these two connectors as added as fundamental building blocks for you to build these applications. So I don't know if you've checked it out yet, but please do take a look at the blog post that I have here at aka.ms link. That will give you a basic idea of just the scenario that we're trying to target. We also have another one coming up soon with the sample for you to try out, including these connectors, right? So there's a scenario that I will share with you right now, which will be available for you to basically play around with Logic Apps. So I think to just give you an overview, right? All these operations for getting embeddings, tokenizing, vector searching, when you are building chat applications and ingestion pipelines for OpenAI, become quite difficult to manage because you have so much of code that you have to write, right? On top of that, you have to worry about authentication. You have to worry about connecting to third-party services that store your data. You have to worry about your vector databases as well, right? And talking to all of them just with seamless, authentication. So how is that possible, without writing code? That's really where, the Logic App piece comes into the picture, right? There are a couple of examples that I've given here for, let's say document processing and automating asynchronous processes. But I think the real value is going to be even beyond the simple pattern of retrieval augmented generating, right? The real value is going to lie in like how you're going to really reduce your costs and automate things, in your organization with Logic Apps, right? So that's where the plugin story will come in for Logic Apps as plugin. We're planning to private preview that next month. So, really seeking if you have any customers who are using plugins, OpenAI plugins, and want to expose Logic Apps as plugins would be great, right? So these connectors are in public preview, right? So they will be available in all regions by the end of this week. So please do take a look at that. And without any further ado, I'll dive into the demo. Let me just share my screen so I can maybe show you the value proposition this product brings. All right, can you see my screen? Wagner, could you maybe shift the, yeah, perfect. Perfect. All right, so let me actually take a look at this particular sample, right? So this sample is from the OpenAI, Azure OpenAI team, right? And what this does is essentially it ingests benefit documents, right, for your organization in this case, and it allows your employees to chat, right? Now, there are two components to this. One is the ingestion pipeline. Second is chatting with your data, right? And for all of that, you're going to have to write a lot of code. You're going to have to use logic apps as a backend to really alleviate the problem. But the simple scenario is that, hey, I want to ask if my plan covers eye exams, dental exams, hearing exams. And to do so, I'm going to have to write a lot of code so that, first of all, I have to ingest all of my scripts, which is going to be a ton of these Python, scripts. On top of that, to manage the infrastructure of the backend, I'm also going to have to write backend code here, right? So that's again going to be, doing all the vector searches, indexing documents, things like that too, right? Now, just look at this, right? This is a lot of folders. I'm going to show you how you can do this literally with 2 workflows, right? So again, mind that you keep this particular scenario in mind, which is the insurance, like the insurance document scenario wherein organization has a lot of documents and they want to make sure that employees take advantage of it. So first of all, let's ingest all of these documents, right? And simply have a workflow here. The new connectors, as you can see, are being public previewed, but essentially, I'm just doing some trigger to actually get that particular PDF. Yet again, here is the power of logic apps, right, people? Because you can actually use any trigger here. You can use a SharePoint trigger, you can use a OneDrive trigger to dynamically keep ingesting the files that are coming in. Or you can even use your, Stack Overflow API to get all the posts on your particular topic, right? So, and then I'm simply composing it in a way so that I can pass into the tokenize function. We will have this operation, which is not live yet, but this will be public. This particular tokenized operation will be public preview next month. But the other ones, which is then for each of the tokens, I'm going to get embeddings. I'm going to index the document. I'm going to create that array to send it to my index, search. And as you can see, I'm passing in, when I'm going to index the embeddings, the content of the particular tokens, or actually the document, right? And the ID. And as you can see, I obviously made that particular AI search service here, which has all of the values, right? Now, great. I've ingested the document. I'm going to play it, and I'm going to actually make sure that this is ingested. And right after I do that, I know we're at time, but I'm going to quickly show you how you can chat with that data, right? So please hang around if you can, just for a couple of minutes. That would be awesome. So as you can see, again, you can have this stateless. It's completed within a few seconds, with the exception of tokenized taking a little bit of time. This will be a really less. We're working on, obviously reducing this right now. But essentially, you can yet again view the inputs and outputs. Something that not all the services offer, right? Like today, if you're supposed to build this with, let's say, prompt flow, you're not going to be able to leverage all these enterprise capabilities, of the third-party connectors and this view of, debugging your workflows and things like that too, right? Then it's again, I'm going to simply go to my chat workflow, which has the other piece of connectors for vector searching and things like that. So chat workflow is pretty straightforward, right? So I'm going to take in the prompt as a string. And once I get the prompt, I'm going to just train the LLM with some system messages. These are just some sample responses that, you don't, these are not required steps. You can obviously skip them. But most importantly, as soon as I receive the prompt, I want to generate the search query. Once I generate the search query, I want to get the embeddings for it, right? And then search, get those vector computations, create the prompt. So now I can get it into the readable, human readable natural language, and then send the response to the chat output. Now look at the power of this, right? You have a linear workflow doing all of this without quite having to write any code, right? And these are just 2 workflows. So now if I'm actually going to chat with it, you can obviously have any particular front-end client to integrate this with. But one second, I'm going to ask the question, right? For example, we are asking the question here. I'm going to ask the same question to my workflow. In this case, if I can find, here it is. And please feel free to drop your questions in the chat as I'm demoing this. So I'm going to run it with payload. I'm going to be like, hey, for the prompt, I'm going to ask, does my plan cover I exams, right? Should run. Yes. And it should give you also the particular, the citation. I'm going to run it again with payload, and I'm going to be like, hey, like, does it like dental too, for example, right? I don't even think it like this asks for dental, but I'm going to ask it. I've ingested a document that does so. So wait, so it didn't done that, right? So that's what's expected. Now I can be like, okay, hearing too, for example, right? That ideally should give us the response that yes, it does, right? So this is what Logic Apps could do for you with just 2 workflows. This is the entire retrieval augmented generation pattern for which a sample that you just saw had to be written with so much code. You can skip all of that, use Logic Apps, and simply make sure that you have these 2 particular workflows that can do the chatting with data and do the ingestion for you. This sample will be available for you to play around with too by the end of this week, or very early next week. So please do feel free to forward it with customers and let me know if there's any particular questions on this. Thank you.
No questions on the chat yet, but I shared the link for the link for your paper.
Perfect.
So people
Thanks.
should be interested on that. I know that we're running 5 minutes late, right? And people started to leave. Other people also have meetings. So I think we're going to be closing here for today, but we keep an eye on the chat. Even if you have questions, please add it to the chat, and then the team at goes to YouTube and try to answer there. But I wouldn't leave the meeting without a shout out to Beza and Aprana, right? Thank you so much, you two, to joining. And as you see, Mike put a really good feedback about the work that Beza was doing. And here is another feedback about the work that Aprana was doing and sharing. Like Wujia was saying that thanks for the details about concurrency control and scaling. I was load testing Logic Apps standard workflow with Service Bus, and I know now which settings to tune. So that is going to be quite useful because, funnily enough, that feels like exactly the crossroads between Aprana and Beza, right? Is the work that you needed control from Logic Apps, but also need the scaling for the app settings. So those 2 things, like the combination of the work from you both. And Sam was saying that's like, thank you, that was super interesting. With that highlight, I think it's time for us to close it for today. Thank you, everyone. And thanks for the DPMs for joining every month with us. Stay tuned for the last Friday of February when you're coming back. Actually, the 4th Friday of February when you're coming back for the next one. And see you guys later.
Thank you.
If I can find our goodbye things. There we go. Bye-bye.